Recording. Okay, this is lesson 1 in the statistics unit for my 40S essential students. We're on page 1 of our new booklet. This unit will primarily focus on solving problems that involve measures of central tendency. These aren't blanks in your book, are they? No, the blanks start on the next page. Okay. So measures of central tendency and calculating something called percentiles. Those are the two biggest problems we'll tackle. But we'll talk about statistics in general when we can. We've already kind of been talking here before I turned on the video that statistics are used in everyday life. They're used to predict weather, figure out insurance premiums, show the abilities of athletes. Right? What is they determine the odds for betting based on statistics from previous performances. All data that you encounter is based on statistics. However, this data may have skewed or half-true conclusions depending on what kind of information we want to pass on. All right, the first thing we're going to do, lesson 1, hopefully this lesson's a bit of a review. Hopefully you've seen these 3 words before. Mean, median, and mode. Together they measure central tendency. Another way to say that is they explain how the middle of the data behaves. So they all represent a central value of the data. Together, these 3 measures of central tendency give a more complete representation of the data. The first is called the mean. Mean is what people usually say when they say the word average. But average is not a technical word in math. And the other things, median and mode, they can be averages too. We'll talk more about that in a few minutes. Mean is also sometimes known as the arithmetic mean. In fact, I think this is the term, arithmetic mean. I think that's the term that Edsby uses in the column that shows you what your average is in the course. Because for the average I use for you guys, I'm actually using an arithmetic mean, but it's a special kind called a weighted mean, which we'll learn about in one of the future lessons. All right, how do you find the mean of a set of data? 2 steps. Add up all of the values of the data set, divide by the number of values. You've seen that before, right? How do you find the average of your 4 tests? Add them up and divide by 4. That's how you find an average. But we're going to call that from now on the arithmetic mean. If you want to get really fancy, the statistical notation for mean is what we call X bar. And actually, even that isn't quite the whole story. This is the statistical notation for the mean of a sample. And what do I mean by a sample? I mean like a piece of the population. Right? It's like, gee, what's the average age at which people I don't know, let's pick something. What's the average age at which people get their driver's license? Am I actually going to count the whole population? I'm going to do a census for the entire country just to find out that piece of information? No, I might do something like get one of those guys to stand in the mall and with a clipboard and ask people as they go by, hey, can you participate in a survey? And then ask, hey, how old were you when you got your driver's license? I'll get a whole bunch of different people, right? There'll be older people, there'll be younger people, and I'll get a nice wide variety of pieces of information. But it's not everybody. It's a sample of the population. The statistical notation for mean of the entire population, mean of a whole population, is actually the Greek letter mu. So that's the symbol. X bar for a sample, mu for the entire population. And when it comes to human statistics, we don't very often talk about the entire population. Okay. All right, that's mean. Median is the middle value of a data set. When the numbers are written in numerical order, either ascending or descending. Do we know what those words mean? Ascending means from biggest to, or from smallest to biggest. Descending means from biggest to smallest. Doesn't matter which way as long as they're in order. What if the data set has an even number of things? Here, I'll do a very quick example for you. What's the median of the numbers 1, 2, and 3? Well, what number's in the middle? 2. That's pretty easy. But now, what if I had the number 1, 2, 3, 4? What number's in the middle? Right. The middle isn't actually one of these numbers. It would be kind of what's in the middle between 2 and 3. So the answer would be, yeah, it'd be 2.5. Now, how do you find that? Well, if you have an even number of values, you take the average, the mean average, of the two numbers in the middle. 2 plus 3 divided by 2 is 2.5. So there you go. That's how you kind of find the median. And again, you should have seen this back in grade 8. Anybody remember what mode is? Mode is the number or numbers that occur most often, is exactly right. The numbers that occur the most often in a set of values. A data set can have no mode. Maybe all the data points happen the same amount of times. Or maybe there's just one mode. There's one number that happens the most. Or there's more than one mode. Okay? You could have several modes in a set of data. Okay, another concept from junior high that hopefully you remember is range. Range is not a measure of central tendency. I'm going to add to that. It is a measure of dispersion. And I just misspelled dispersion. Anybody take a guess what that word means? If I say something's very widely dispersed, what does that mean? It means it's spread out a lot. So dispersion means how spread out data is. And range is easy to find. It's just the biggest number minus the lowest number. That's your range of data. All right, let's do our first example. Am I going too fast? I'll slow down a bit for you. There. Can you still see? You're good? Okay. Mean, median, mode, and range for those data sets. That set of data, please. Okay, so let's do the mean first. It's kind of the most work. Mean has a formula. And the formula, you can see from your new formula sheet, they just put it in words. They say it's the sum of all the data divided by the number. Would you like a formula for it, like with symbols? Here's how a statistician would actually write it. First of all, is this a sample or a population? You know what? I don't know, so I'll just assume it's a population. So mu is equal to, how do you say the sum? There's a Greek letter that we use for sum. Anybody know what it is? Close. Delta means change. Maybe you learned that in physics or in your science classes. Delta is the symbol, the Greek letter we use for the symbol for change. The Greek letter we use for the symbol for I'm going to add everything up and make a sum is sigma. Sigma. Sigma x, where x means just the data points, the variable, over capital N for all the numbers. Okay, so let's do that. How much is the mean? It's going to be 55 plus 78 plus 70 plus 77 plus 62 plus 78 plus 39 plus 45 plus 72. And I don't know about you, but I like to make sure that I didn't lose anybody. The most common place I make mistakes when I'm making answer keys and stuff is I miscopy the stupid question. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 marks here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So the only way I could goof it up now is if I add wrong or if I wrote one of them wrong as I was doing it. Okay, so I'm dividing by how many things? I just counted 9. Okay, let's get an answer for that. I would like to add all those numbers. I would probably use my calculator for that. Maybe not. I want to try it without. 55 and 78 is 133. 203. 273, 280. 280 plus 60, so that's 342. 512, 520. Oh, I've lost it. Rats! Too much. Anyway, I added it all up. I got 576. That's what I got. Try it again. Somebody want to punch buttons and double check? But I got 576. All right, let's get the calculator out. Okay, maybe I punched buttons wrong then. All right, let's give it a try. Ready? Okay, so we punch buttons. Come on, calculator. Come on, calculator. It won't come on. It won't come on. There we go. There we go. There we go. It is 76? Well, no. Okay, there we go. There you go. And that would put you off by 30, which makes it exactly why. Yep, so there you go. Okay, I'm not going to bother wasting my video time on this. I'm pretty sure it's 576, and now we have other people who've confirmed it. Now I just divide that. So what is 576 divided by 9? 64. So I would say the average mark in my class, if I'm using mean for my average, is 64. That's the measure of the center of my class. 64 is what the average kid got in that test. All right, so that's mean. Let's do median. How do you do median? You line them all up from smallest to biggest or biggest to smallest. I'll go smallest to biggest. Here's how I do this. I start by going, okay, what's the smallest number in my data set? 39. Write it down. Any more 30s? Nope. Any in the 40s? Yep, 45. Any in the 50s? Yep, 55. Any in the 60s? Notice I'm crossing them off as I go so that I don't lose anything, don't lose track. Any in the 70s? Oh, a bunch. 70 is the smallest, then a 72, then a 77, then a 78. Then another 78. Do I have to write it down even though I already wrote down 78? Yes, because you have to have all 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. Okay, now, without making my life too hard on myself, how do I find the middle of 9 numbers? It's the 5th number. How did I do that so fast? There you go. If you have an odd number of data points, take the number of data points you have, minus 1, then divide by 2, and then add 1 again. And that will be your middle number. So I had 9. 9 minus 1 is 8. 8 divided by 2 is 4. 4 plus 1. It's the 5th number. Another way you could do it is to just sort of count. Go, it's not that one, it's not that one, it's not this 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 one. I hit the middle. Count from both ends until you hit the middle. So the answer for the median is 70. Now here's where we start talking about using statistics to promote an agenda. Let's say I was teaching at one of those schools where, and believe it or not, these schools exist in the United States, and I'm very glad I don't work at one. I will actually get paid more if my students have a higher average. Guess which average I'm going to use? I'm going to use the median. Hey, the average on my class was 70%. Let's turn that around. What if I am trying hard to get more funding for my school, and the government policy is schools that have more kids at risk get more funding? And it's in my best interest to say, oh, the average in my class was only 64. Neither one of those two arguments is wrong. You can use mean for an average, you can use median for an average. But sometimes it makes more sense to go one way than the other. If the data is all pretty close together, notice there was nobody in this class that got a 2. There was nobody that had 100. There were no extremely big or small numbers. So mean is probably the best way to do the average when there's no extreme numbers. What if I had all this data and then I had a couple people who got 0? Like they literally showed up, write their name on the test, and walked out. Now what? I think I'd for sure use median. Because notice, can I point something out to you? If I added a 0 to this information, don't change your numbers here because the example is written the way it is on the page. But if I added a 0 to this information, to this data set, Notice it only moves the middle over to here. And what's halfway between 62 and 70? I know we better figure that out. 62 plus 70 divided by 2. That's 132 divided by 2. 66. So my new average would be 66. Notice the median would not change very much if you put a really big or really small number on the end. But if you do that for the mean, it would change things a lot. Another good example is if you ever read a story about average salaries in professional sports, right? You could have a professional sports team where one player on your team makes $10 million and the next highest paid player makes $2 million. And if you say now only have 20 people on the team, one guy makes 10 million and all the other guys make lower than 2 million, is adding them up and dividing a good way to do average? No. You'd be better off doing median, because this number is going to, and again, the word for that is skew the data. It'll skew the central tendency too high. You'll say something like, oh, the average player makes $6 million. One guy makes that much. Everybody else makes more, like way less than that. So keep that in mind as we're going. So that's median. All right, what's mode? One of the best things about doing mode after median is, oh, they're already in order for me. Which number happens the most? There it is. I'm going to tell again, if I work at that school where I get paid more if my students do better, my average score was 78%. Now you're probably thinking, where in the real world would you ever say that the average number is the number that happened the most? Actually, I can think of a few. Maybe my favorite example is, what if I ran a shoe store and I wanted to know the average size of my customers? Would it make sense to add up all your sizes? Okay, the first guy that walked in bought a size 6. Second guy bought a size 9. Next guy bought a size 12. Next guy bought a size 14. He was some giant mutant guy. Am I going to add all those numbers up and divide? I might get the size 6.7. I don't even have a 6.7. They don't make sizes in decimals. It would make more sense to just go, oh, the average size is whatever I sell the most of. Mode. So yeah, sometimes mode can be your average. So that's why in this unit, the word average, we're going to try not to use it very often. We're going to say we want an arithmetic mean, or we want a median, or we want a mode. Sometimes we'll decide which of those best represents the middle of our data. And which one it is kind of depends on the situation. All right, next example. How about I pause and let you try to come up with the numbers and then see if we get the same numbers. So guys doing this at home, pause your video, try to find mean, median, and mode, and notice it tells you where to round this time. Okay? So I will pause the video, give that a try, turn that video back on once you're done. Okay, we're back. So, come on, there we go. So, I added those numbers up, and on top, I got 637. Now, obviously, it'd be a drag to just re-add the same numbers over and over again. It's not a bad idea to just be able to maybe estimate a little bit. Like, for example, they're all around 100. So 100, 200, 300, 400, 500, 600. That kind of makes sense that it's around 600. And then, you know what? You could always just find the last digit. 7 plus 8 ends in a 5, plus 6 ends in a 1, plus 2 ends in a 3, plus 6 ends in a 9, plus 8 ends in a 7. I'm in the 600s, and I end in a 7. Chances are I did this right. If I'd have made some sort of mistake, probably one of those two things would have not worked out for me. So there, that saves you repunching buttons twice. Because on a test, you wouldn't have that kind of time anyway, right? All right, but I still have to actually do the calculation. 637 divided by 6. They said round to one decimal place, so let's make sure we round properly. Turn my calculator on. There we are. 637 divide 6. Okay, where do we round? Where is the tenths place? Is it the 1 or the 6? Are you saying that there's a 1ths place? The 1. So it's 106.1, but the thing after the 1 makes it bigger, 5 or bigger, so that makes it 106.2. 106.2. Yes, when we test you on this unit, if you round wrong, you lose half a mark. So make sure we're rounding properly the way they taught us back in elementary. Okay? All right, median. Okay, I put them in order, but aha, go back to the first page on the notes. We have a situation where there's an even number of values, right? There's 6 numbers here. What's the middle of 6 numbers? Well, it's whatever's halfway between the third and fourth number. So I take 102 plus 107, divide it by 2, and when I do that, I'm going to get 209 over 2, which is 104.5. And again, we wanted answers to the nearest 10th, so good enough. That's the middle of that data, 104.5. Mode, as somebody pointed out a minute ago while the camera was off, there's 2 of them. The number 96 happens twice. The number 118 happens twice. So there's 2 modes. What if all the numbers happen twice? Then I'd say I don't have a mode. I don't have 1 or 2 or a few values that happen more than the rest. So you can have no mode, you can have several modes. All right, any questions so far? All right, why don't we give you guys a minute to try example 3. I'll read it with you. A grade 12 class with 15 students was polled to determine the number of handheld devices. I assume they mean electronic devices, like iPads and iPhones and smartphones. The number of handheld electronic devices in their homes. Here's the results of the students provided. After the results were in, one of the students states that the median of the set was 1. What error did they make? And then do the calculation, what's the actual median? And then from there, what's the mean and what's the mode? So I'll give you a couple minutes to try this question, and then we'll meet back here. Guys at home, pause your video and give it a try. Okay, we're back. What error did the student make? What do you think? This student did not put them in order. I get it. They went, okay, where's the middle? There's 1 there. There's, let's see, how many students is 15? So 15, half of 15 would be 7.5. So the 8th number in the data set. 1, 2, 3, 4, 5, 6, 7, 8. There, it's 1, and that's how they got their 1. So let's put that into words. The students, they did not, I'll say, arrange the data in order. So the actual median, my bad, would be, okay, how many 1s do we have? 1, 2, 3 1s. So 1, 1, 1. How many 2s do we have? 1, 2, 3 2s. 2, 2, 2. How many 3s do we have? 1, 2, 3. Oh, we got 3 3s. 1, 2, 3. How many 4s do we have? I'm sensing a pattern. 3 4s. Oops, so much for my pattern. I only got 1 5. I only got 1 7. And I only got 1 8. All right. I like to do this to make sure I didn't lose anybody. It told me in the question there were 15 data sets. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Phew, I got everybody. Where's the middle now? 1, 2, 3, 4, 5, 6, 7, 8. The median is equal to 3. What's the mean of this data set? Okay, let's shortcut our life a little bit here. The mean is, again, add them all up and then divide by how many things. Well, I already know from the question, they told me it was 15 things. But why don't I make my life easier? I know what 3 1s is. 3 1s is 3. I know what 3 2s is. 3 2s is 6. 3 3s is 9. 4 4s is 12. And then, 5 plus 7 plus 8, that's easy to do in my head. 15 and 5, 20. Add all that up, and you actually get 50 divided by 15. I'll use the same rule I used last time and round to 1 decimal place. I believe that's 3.3 repeating. So I'll round to 1 decimal place. 3.3 is the mean. Okay. What is the mode of this data set? What number's in the middle? Or sorry, say that backwards. What number happens the most? That's what I meant to say. What number happens the most? Yeah, there's actually a few, right? There's 3 1s, 3 2s, 3 3s, and 3 4s. So I would say all of them are the mode. There are 4 modes of this data. 1, 2, 3, and 4. All right, I can see from the look in some of your faces. It's like, what? I did this in grade 8. How dare you insult my intelligence? Fine. Here's a question that's maybe a little higher level than I would have given to a grade 8 student. What do I do in this question? Okay, in a small restaurant. Now, some of my picture here did not copy properly, so I'm going to have to kind of write it down as we go. You guys are looking at your notes booklet. There's a bunch of things here that somehow did not translate when I moved the file over. Yeah, I can see from your booklet on your desk that you've got some data here. So I'll write it down as we go. In a small restaurant, the employees are trying to convince their manager they need a raise. The diagram below, or to the right, displays the salaries for each position. Okay, so here they are. This first arrow is for supervisors. And supervisors, there's 2 of them, and they make $34,000 per year. The next arrow in the diagram, actually these aren't arrows, they're called chevrons. There you go. Hey, we learned that in geometry. The next chevron was servers, and there's 9 of them, and they make $21,000 per year each. Then the next chevron, the next piece of information, was that your bartenders at this restaurant make $26,000 a year, and there's 3 of them. Then you've got your kitchen staff, your cooks. There's 7 cooks at this restaurant. They make $31,000 each. And then finally, there's the people who greet you at the door and seat you, your hosts, hostesses, hosts. There's 2 of those, and they make $16,000 a year. So you didn't have to copy this down. This was in your booklet. It just, for some reason, kind of got lost when I copied it to my notebook page here. Okay. Which employee is correct? One employee says the mean salary is $21,000. Another says the mean salary is $26,000. The third employee says, no, the mean is $25,391.30. Well, I don't really know which one's correct until I calculate the mean, but let's be smart about this. Let's do this the same way I kind of did those, where it's like, I don't have to add 1 plus 1 plus 1. I know that's 3. I don't have to add 2 plus 2 plus 2. I know that's 6. Notice that there's how many pieces of data here? The mean is add them all up and divide by the number of things. So how many things am I looking at here? Actually, I better do this on the next line. I'm going to need more room. How many things, how many people do I have working at this restaurant? There might be people go, oh, you have 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5 people. No, there isn't. There's 2 supervisors, 9 servers, 3 bartenders, 7 cooks, 2 hosts. Add that up. 2 plus 9 is 11. 11 plus 3 is 14. 14 and 7 is 21. 21 and 2. There's 23 people working at this restaurant. Why don't I make my life easier and figure out the sum of the 2 supervisors? Take your calculator and go, what is 2 times 34,000? You know what? I probably don't need a calculator for that. That's $68,000 paid to the supervisors. So that's going to be my first thing I'm going to add, 68,000. Next, I have 9 servers. Why don't I take 9 times 21,000? That's $189,000 that if I'm running this restaurant, I got to pay out to my servers. So I'm going to add 189,000 down here. There's 3 bartenders. What's 3 times 26,000? That I might need my calculator for. This is getting kind of hard to do in my head. So I punched this before. I got 78,000. 78,000. Cooks. 7 cooks that each make 31,000. What's 7 times 31,000? 217,000. So I'm going to put 217,000 right here. And then finally, 2, that one I can do in my head. 2 times 16,000 is 32,000. So I'm going to add 32,000. Okay, you know what? When I punch this on my calculator, notice that all of these numbers just have 3 zeros at the end. Want to make your life easier? Why don't you just add 68 to 189 to 78 to 217 to 32. Get an answer and then times it by 1,000. Puts the 3 zeros back. If you do that, you get $584,000 of salary that I have to pay if I run this restaurant. Divide that by 23, and you get $25,391.30. So, what does that mean? The third employee was correct. So I'll put that over here. So, third employee was correct. What do you think the other two did wrong? Take a look at the answers they got. The first employee said that the mean was 21,000. What do you think the employee did wrong? Look at the data. Why would you think that it was 21,000? Where do you see 21,000? That's how much the 9 servers make. So guess what that number is? The first employee confused mode with mean. Right? Because 21,000, I'll put that in brackets, 21,000 is the mode. Any guesses what the second employee did? The second employee said that the mean, according to their calculation, was 26,000. Guess what number that is? Well, let's see. If I were to line up all of these salaries in order, there's 15 of them. What's the 8th one is the middle? So the first 2 would be hosts. The next 9 would be servers. That gets me to 11. Oops, didn't need that to come up. The next, what's the next one after 21,000? The next 3 are bartenders, and that gets me to, so 2 plus 9 is 11. Oh, wait a minute, hang on. What did I say there was again? There's 23, my bad. 23 employees. So 23 employees, the middle of 23 numbers, the median of 23 values is the, okay, what's halfway into 23? 11 plus 11 is 22. So the 11 and a half, so the 12th. So the 12th number. So let's see, let's count that again. Where's the 12th number in this data set? 2 of them are supervisors. 9 of them are, let's start at the bottom. 2 of them are hosts. That's the smallest. So then the next smallest are the 9 servers. So that takes me to 11. So the 12th would be a bartender. So the second employee confused median with mean, and 26,000 is the median. So there we go. Finally, there's a C part of the question which asks you for something more like an opinion. Remember, I can say my average is my mean or my median or my mode. Which measure of central tendency should the employees use to argue, hey, we need to get paid more? Well, I would say the first employee, the one that actually messed up and used mode, the first employee has the smallest measure of central tendency. I'll just say measure. I could again say the smallest average. Again, that's not a technical word. You can use mode as your average. So the first employee used mode for average, and that's the smallest number. So it strengthens their argument. It's like, hey, we get paid not enough. Look at that, our average salary is $16,000 amongst our 23 employees. Well, that's the mode average. But yeah, that's the smallest number. So if I was making that argument, that's the one I'd use. But I guess you could argue the other way. Hopefully the boss, the owner of this restaurant will go, wait a minute. You're saying the average salary is $16,000 for my 23 employees? No, that's the most common salary amongst my 23 employees. But median might be more fair to the employer. So it kind of depends whose side you're on here. Are you on the side of the restaurant owner? Where it's like, okay, come on. I pay good wages, but I can't pay my servers as much as I pay my cooks. And those hosts, all they do is stand there and say welcome and smile and sit people down. They don't even carry food back and forth and take orders. I can't pay them as much as the servers. I'd go out of business if I raised my employee wages too much. There's got to be some sort of a strata here of the employee wages. So if you want to argue on the case of the employer, you'd say, hey, come on. You didn't make a fair argument saying my average salaries I'm paying is $16,000. Or sorry, is $21,000, because half of my employees make more than that. So I might use the median to be more fair. So that's the kind of question I probably wouldn't have asked grade 8s. That takes some reasoning, some logic, even a little bit of empathy towards the working man. Grade 8s ain't had no jobs yet. You guys have all had jobs, I would think, or at least many of you have had some part-time jobs. So that's a little more of a grown-up question. Notice the math, though, is still the same. How do you find mean? Add them up and divide. How do you find median? Put them in order. How do you find mode? Which one happens the most? Okay? I just realized just now, we're going to go back real quick to example 1. I missed part of the question for example 1. What did I forget to do? Look at the question. Can everybody go back to example 1 real quick? Oops, that's too far. It said find the mean, median, mode. Oops, forgot to do the range. Okay, so what's the range of my data? Go back to example 1, everybody. Biggest number minus the smallest number. What's 78 minus 39? You can use your calculator to help you if you want. 78, oops, clear. 78 minus 39, and you get 39. And that's how you find range. All right, you are now ready to do your first workbook assignment. It is in your brand new workbook that I just handed out. And it's the 4A page. There it is. Mean, median, and mode. So you have the rest of this class to work on that. I'm going to stop the video now.